Hey guys, so this is a follow-up with our challenge in our previous video. If you haven't seen the previous video, the link is available in the below description. Make sure you watch it first and catch up then with this one. We launched a challenge in that video and here is what it was. You have a triangle ABC and each side is prolonged with its own length in these directions. And then we have the 3-point A prime, B prime, C prime built, and this is a new triangle that's being formed here. For the reference, these lines here are equal. And the challenge was the following. We have to erase the triangle on the inside, and the question is, how can you build it? So everything that's red here has to go out. For the sake of the video, I'm not going to erase it. It will make a lot of mess. But let's consider everything that's red going out. And the question is, how can we build the ABC triangle back? While watching this video, pay good attention because at some point of the solution, there will be a little trick, and that will be the question, the topic to challenge for our next coming video. Do you think you can spot the trick? Make sure you like and subscribe to see our next video. If you spotted the trick, comment in the section below. Here's the solution that I want to propose to you. We have our inner triangle here. We built another one. We have absolutely nothing in the middle. And in order to build the triangle back, we will take now, again, one even bigger triangle. Let's do it like this. We will call this point A second, B second, and C second. And here we have a new triangle being formed. And what we want to prove now is the following. The inner triangle ABC can be built by observing that AB and A second, B second are actually parallel. So taking a parallel to A second, B second through B prime will yield one side of this triangle. And conversely, because AC is parallel to A second, C second, we can build by drawing a parallel to A second, C second through A prime. So this line here is actually parallel to this one. This line here is parallel to this one. And this line here is parallel to this one. Now take a few seconds, pause this video if you want to attempt the solution of how to prove that AB is actually parallel to A second, B second, and resume afterwards if you want to see the solution that we will take. Let's start from a simple principle again. If we have one segment, let's call 2 points P and Q. And we have the middle segment here called M. And P is a point of coordinates. We will go now into analytical geometry, XP and YP. We have Q of XQ and YQ. And then we have M of coordinates, XM, YM. We have the following property that XM is equal to XP plus XQ divided by 2, and Ym equals Yp plus Yq divided by 2. What we want to do is find the coordinates of xp and yp depending on xm, qm, and ym and qm. And this is fairly easy to see that xp is actually equal to 2 times xm minus xq, and yp is equal to 2 times ym minus yq. And this is a property that we want to use further in our proof. Let's take for start the coordinates of ABC. This is quite easy. A has the coordinates xa and ya. We have B coordinates xb, yb, and we have C coordinates xc and yc. Now, when we look at this one, we can see A is the middle of the segment A prime C. A prime will have the coordinates, according to this formula right here, 2 times the x of A minus the x of C. So we have 2 xa minus xc, and for the y, it's in the similar manner, 2 times ya minus yc. Now, moving further for the B prime and the C prime, we can directly write their formula. So here it is. These are the coordinates of A prime, B prime, C prime. This is just simple calculation that has to be done. We want to go further now and check the coordinates of A second, B second, and C second. And in order to do that, we have to see that A prime is the middle segment of A second, B second. So that means that the x of A second is equal 2 times the x of A prime minus x of B prime. And that equals further to 2 times, and the xa prime is this one, 2xa minus xc minus, and here we have xb prime is this one, 2xb plus xa. I directly put this minus sign over the parentheses. And this goes further as 4 times xa minus 2 times xc minus 2 times xb plus xa. And this further goes as 5 times xa minus 2 times xc minus 2 times xb. Now let's directly write all the coordinates of A second, B second, C second based on this formula, because all the other calculation will be similar. So finally, these are the coordinates of the ABC, A prime, B prime, C prime, and A second, B second, C second. Now, in order to prove that AB is parallel to A second, B second, we want to take the following approach. And we're going to take a look at the slope of AB. M, let's call that the slope of AB. This is equal to, this is a general formula, it's the YB minus YA divided by XB minus XA. And now let's take a look at the slope of A second, B second. And this is equal to the Y of B second minus the Y of A second, divided by the X of B second minus the A of A second. And here's what's happening next. These two guys here go out, these two guys here go out, and this one right here together with this one, they go together, and this one right here with this one, they go together. And it goes 7YB minus 7YA, and on the bottom line it's the same, 7XB minus 7XA. And when we simplify this with 7, we get YB minus YA divided by XB minus XA. And this is actually the slope of AB. So by this, we have proven that the lines AB and A second, B second are actually parallel. What does that mean? It means that if you completely erase this inner triangle and you build up this bigger triangle on top of it, you can take the parallels through B prime, C prime, and A prime to the newly constructed triangle, and you get back the smaller triangle. Now again, in this little proof here, I have left a little bit of a trick. Can you figure out what the trick is? And as a hint, if you spot the trick, you will see that if you have absolutely no information on the initial triangle and how A prime, B prime, C prime was actually built, you can't directly know how to build it back. If you figure out, make sure you comment in the section below. Don't forget to like and subscribe and see the solution in one of our next videos. Until next time, have a good one.